very beautiful. I'll explain the interface. Let's see this as an example. You can deploy and test your smart contract. You also have accounts. These accounts, they're already AE deposited already for you using the test net. You don't have to fund. If you are using this compiler, and you want to test, you have to fund your test net address also. Then you utilize it also. But if you are using the AE Studio, which is far better, you don't have to go through all those stress. It's already done for you. So you just pick any wallet you love to deploy. You pick any wallet you love to deploy, and also you deploy it on the wallet. So let's go for that. Okay, I would minimize the noise on my background, and see how I won't be having that noise anymore. Okay, so let's go on. So you can deploy on this, but we won't be using this. I'll be writing a fresh one. We will be building a file application. Now, the Giantsec community is more of a cyber security community. So we'll be discussing also use cases for cyber security, and be sharing thoughts on that, and see how we can begin to apply blockchain technology. It is blockchain technology for cyber security. It's very special because blockchain's technology is a decentralized, secured, you know, tech, protocol that you can use in ensuring that there's safety on the web. We'll go further to discuss about the superhero wallet. You can connect your superhero, and before the end, see how we can connect this also. You can connect your superhero wallet. I'll explain more what the superhero wallet is later. You can connect it if you are going to take your app on the mainnet. You can connect it, but we are using the test net because we would love to um, spend tokens for testing. So we'll be using the test net. Since this is more of a learning, we are all being introduced to everybody joining now. We came to learn about. We came to have an introduction to AE development. You can connect your GitHub um, account here also. I connected mine. You can also share. Um, you can also share also, but this feature is coming up very soon. So what we'll be building if you come to darky.org, which has a very detailed course on eternity development, beginners course, you know how to build. Now we'll be focusing more on the smart contracts. You can also connect your smart contract to front end, more of the client end, using JavaScript, HTML, Bootstrap. You can have a front end that you can interact with your back end. The back end, which is more of the smart contract, and so you can have that also by using an address. We'll be going into all that. You can come to darky.org and get a full course on that. You also get introduction to programming, if you're pretty new to program. But I believe everyone joining here, we are all programmers and we are used to it. So I won't be going through a lot of introduction. I'll go straight to the core of the event, and I also talk about the syntax also. Eternity has a different. Sophia has a Okta like syntax. You can come to okta.org to learn about of and Sophia language, and this can give you like a background overview of Sophia before coming in to learn about Sophia. So you can come here to learn about that also. They have a documentation also, so you can come and learn about functional style of programming, and also before coming to learn about eternity programming. Now, this is the A Studio. Now, we'll be building a file application. I picked this because it's very easy. It's very easy and straightforward, and I did an extensive work of breaking everything down also. I'll be writing the smart contract code from start also, but I'll make sure I explain every bit of it as we go on what I'm trying to do at every step and how you can also achieve this. Also, if you are building, also if you are using this to test. Now, I made this available on my GitHub. You can come to my GitHub and see this. I did an extensive job on it. It's in my repository, so you can come on my GitHub and you see test.ae. So I made that also available. So this is okay. All right, this is my GitHub repository that you can come on, and I'll be sending the links to the lead Josh, so that he can share with you guys on the comment section, and you all can also see, go through this. Also, I did an extensive job, so you can come here. This is my GitHub. This is a readme file for it. If you want to learn the complete guide to the tutorial, this is the complete guide. This, if you want to learn C Sophia documentation for that learning, you can come here and go to Sophia documentation. There's theoretical tutorials on what eternity smart contract is, but we'll be focusing more on the Sophia documentation also, and we'll be using that to see how we can use. This has a full the Sophia language is full. It's a library. It has everything you need to know in building your decentralized application, how to get started, the the syntax of Sophia, and all of that. Now let's go into the the core parts of today. Now we're building a file application that will be able to store file. You can also store videos also on this application. You can store video on this application. You can store file. This is a Giantsec community, a cyber security community. So that's why I picked this app also, because it's relative to securing, like saving your work and not losing your file. And that's why I picked this also. So we'll be using this as an example. Now we'll be using IPFS. IPFS is a platform for storing, for saving files, but you'll be able to save files and get the hash of the file. So getting that hash of the file is what we then use to call the file and have it displayed on the blockchain. Now we won't be saving an image directly on the blockchain because it's very expensive. You talk the fee, we just have few here for test. And if you're saving file directly on the blockchain, like videos, images, you spend more. You spend more. So that's why a platform like the IPFS is there for you, so that you can save your file on and call it on your smart contract. So that's what we'll be using today to see how that'll be very easy for us to use also. So we'll be writing a smart contract. Our smart contract will be building a file application. Now, I made it very easy, so I would be going deep into it right now. I know I will assume everyone joining us are developers. So we'll be going through. If you want to learn about basic, then you can go and learn about HTML, JavaScript, and all of that. But Sophia programming language is very easy to write. It's very easy. It's I know, so Solidity is very complex. If you are using Solidity on Ethereum, it's very complex. Sophia is very easy to write. The syntax, it's pretty much like the Python programming language style. It's very easy to use and very easy. So right now we're building a file application. Um, Building a file application. So what we'll be doing today is going to be in three steps. It's going to be in three steps in building this application. And the first would have to model out our file objects. That's what the first thing we have to do. We have to model out our file objects. That means we are going to be seeing giving um, You are going to be seeing giving types like the integer, the string, the bool. If you come to the Sophia MD, you see all of this right here. Let me go here and explain that also. Types. Now Sophia has the following types. They have the integer, which is, we know that integer is more of a number. An address, we have the address, which is your address, the address of like your testnet address, the address of the user using the application. Now we also have the bool, we also have the bits, we have the string. The string is more of the string is more of like you are writing text. I'm just using a layman's interpretation so we can all understand. We have the list, the record, the map, the option, the state, the event, and all of this. We'll be using some of these types in building our application today, and we'll be using um, mutable types. We'll be using immutable types because we love our smart contracts to be able to change. And also, so first thing, we'll be modeling out our file objects, and the next thing, we would create and add a file functionality. We'll create a file functionality, so you will be able to add a file after modeling out your file object. You then create We will then create a add file functionality. Then we'll also have the we also have a way of retrieving the files that we have on that we added on our smart contract. Now you see all this in practical when we deploy and test the app. You see how we can get these files also, and also get know how many number of files have been updated on our smart contract, and we go all and all in all this. So what we do first of all, it's to call the keyword contract. Now if you are writing a smart contract on the Sophia, you first of all call the keyword contract. You can it's a smart contract, so it's you call the keyword contract. Now if you come here, you can read more language features, you can read more on contract to interact with the blockchain and contract. We refer to the chain contract, and all of this. Now you come here, this is a documentation for Sophia programming language. So you come here, and also I'll be very I'll make sure we are fast because we are really going short of time, so we can complete this also. So first of all, call the keyword contract. If you're writing a smart contract, you call the keyword contract. Now what are we building today? We are building a file application. For example, if you are building a voting application, like if you come on darkade.org, the example that was built here, it's a voting, I'll vote this meme and all of that. So what we'll be doing, so for example, if you are building a meme voting app using that as an example, we have to call this, we have to call it a meme voting app. Okay, we have to give it, but we are not doing that. We are building a file app. So you would and you also see this also up here. It will then changes from crypto hamster to a file. So we'll give it a name, which is the file. Then we set our value, and would then first of all remember, we are going to model object that we'll be modeling out the file object. We'll be giving an ID. Okay, an ID, the name. The name is going to be the address of the user. This is blockchain, so we are not dealing with your real name. We are dealing with the name of the user. Now if you are not familiar with blockchain technology, please just hang around. I would give a overview, then you understand better what you are doing here. This is a developer meetup, so I would go straight diving into the building our decentralized application. So first of all, you would now you're going to then have a record. we're going to then create a record. Now, in modeling out our file object, we have to, model it out on a record. So the smart contract has a record of, the file object that we are modeling out. So the record of the file object will contain the ID of the file, the name, which is the address, description, which the description of the file. For example, if we deploy, you see that the description of the file, we are going to upload an image. So it's going to be, maybe it's my image. I'll say the description of the file will be success image. So that's the description. The created date, the date it was created. We are going to also update it also. Now the time it was updated. Also, we are going to have it in our file record, in modeling out our file object. The owner too is going to be the address. Okay, the owner too is going to be the address. Then the hash also is going to be a string. So the hash will be when we upload an image here. Let me just show you an example of the hash, so we are following and we are understanding it basically, so that we can really get what we are doing, and be gingered up to go practical after this event. So for example, I upload this on IPFS, I'll get the hash. This is the hash of the file. Now if I copy this and post, you will see the image that I uploaded. You will see the image that I uploaded. Now this is the image that I uploaded, so that's basically what we'll be using. Remember, I said we cannot upload our image directly on the blockchain because it will be very expensive for us. We talked about the downside of blockchain. The downside of blockchain is that, one, it is expensive to use. It is very expensive, and that's been a challenge for building real world application. And so we have so many platforms coming up to apply blockchain for database, file storage, file management. So that also makes the work easier for us to be able to utilize this without uploading on a blockchain. We can get this hash from IPFS and utilize on our program. Now, this is, so first of all, we're modeling out our file object to have a record of this. Now we'll be using the keyword record. You can come here also to see this. Let me show you guys how I came about this, so it doesn't look as if we are doing something that you don't know. Now this is its record: an immutable key value store with fixed key names and type object. Okay, this is a record. This is an example how to create a record. Okay, so this is how I came about that. Now we'll be installing, it's going to be an immutable what key. So we have to change. This is what we are going to be using, to model our smart contract from beginning to the end. So it's an immutable key value store with fixed key names and typed values. So this is how I came about. Record, we'll create a record, and it's going to be our file record. It's going to be our file record, and we're going to impute our our file record, the objects. What we'll be modeling out, we'll modeling our file object first. So we'll be putting the record of our file in this first of all. Now remember, here I wrote this out. The ID is going to be an integer. It's going to be a string. Now we can come here and see all of this here also. Okay, an integer, a two complement integer. Okay, and it doesn't have to be -1. It doesn't have to be -1. And all of that. You know what an integer is. We all know what an integer is, so you should know what an integer is because we are all developers. Okay, so we'll be having, let's model out our file objects first of all, so we can go further from there. All right, now we'll be having an ID. an ID. So let me quickly do this. I'll make this as quick as possible. Now, Sophia, it's the compiler. It's a very sensitive compiler. It's a very sensitive one. You'd be able to see. You pay attention to. You pay attention to your indentation. For example, if you're writing on this compiler and you not pay attention to your indentation, you may have errors, on your code. You may have errors and you'll be able to deploy your smart contract. Okay, so you pay attention to that also. That's a tip I'm giving us. So in case you are writing your smart contract and you start seeing errors, there's if you come here, you see this is also a compiler. If you're having errors, this will give you an overview of the errors you're having. Now we have an error here also. I already know what is the cause of this error. So if you're this gives you an hint. If you're writing your smart contract and you have an error, this gives you an hint that okay, this is where the issue is. And it also tells you the line. It tells you the line of code that you're having the error from. Okay, so that's a tip for using this. That's why the AE Studio is the best, and it's far better than when you're using this contract compiler. Okay, now let's go on. Now, our name is going to be a string because the reason why in programming, name is more of a string because I don't think there's anybody that has a name that has to do with a number. You can't say an ID, can be an integer. So we'll be using this an ID as an integer to say okay, an ID as an integer, but the name must be a string because I don't think there's anybody that bears a name that has numbers. So let's go on. Description. So we'll be having a description now. Be having the description also, and this the description is going to be a string. Because remember I said when I upload this image on and we get this hash and we are utilizing it on our smart contract to call the image. Okay, now let's go on. Okay, I'm having an error here. Okay, I got I spelled wrongly. So you take note of this in programming. It's always there. So that's why there's the issue of going through your code also and ensuring that you're doing the right thing. Now created at, so we'll be using, remember the created date is going to be an integer. You're going to see all this also uh, when we create an add file functionality. You see actions to interact with this also. Now let's go on. So we are creating a created at. This is going to be an integer. Okay, then we have the updated at, which is going to be an integer also. So then the owner is going to be a string. The owner will be the address of the guy who, for example, who deployed the contract. If you are working with this on the client end, or like you're connecting it to, you're using an SDK. Sophia has SDK for Python, for JavaScript, and that if you're interacting with your smart contract with the front end, I'll try to show us an example of that also going forward. Now the owner is going to be an address. Going to be an address. Okay. Then the hash also. Remember the hash is going to be the hash that we get from IPFS. Okay, it's gonna be a string. It's gonna be a string. Now, in normal, like for example, you are coding in JavaScript. You know that you have to. Now we were getting an error recently because you have to take this back in Sophia. Sophia, the compiler is a very sensitive compiler. It takes into record of indentation. So you have to take your you have to close your code. You don't have to leave this space. You don't have to leave it. To then you won't be having any error anymore. Okay, you'll be having an error. So you see, let me show you this also. I took this back and I was having an error until I indented. I gave it a space and then I didn't have any errors. So if you, in case you're having errors, you know where to tackle it from. Now we're going to be next thing we'll be doing is we are going to then create a state which will keep track of everything. We are going to create okay we are going to create a we are going to create a state which will keep track of everything we do on the smart contract. That's what we are going to do, like modifications that we make. So we are going to create a state for that. Now let me explain. Here also we impute values that might change during the writing of our smart contract. In creating a state using the keyword state, you are saying you are giving you are creating values that might change and in the course of your smart contract. So here we also impute values that might change during the writing of our smart contract. Values like record, we use the mutable state. Now remember, this our record, this our file object is an immutable. We created it to be an immutable, to be in an immutable state. So it will change going forward. But yeah, we will also love to modify this also going forward. So we then use the state, to create it is fun of. And let me show you this also in explaining this properly so you understand also. Now let's look for the word. Now let's look for the state. Let's look for the state. Okay, now the user defined type holding the contract state also, it's mutable. It can change. We have immutable types that cannot change, like for example immutable types that cannot change, like the record that we have. But this is an immutable. This is immutable. We are saying we are giving it a type that okay, and we want this to also modify our contract in case we be having any changes. So we love to modify. It's more of a way to modify, to tell your compiler that okay, this will be able to, in case we would love to modify our contract from any modification, we'd also have to give room for that also. Now let's go forward. And wow, okay, I think I just that's so I'm writing everything. Start again. I'll go speed. So we'll create a state in case to be having anything that might change. Um, so in case to be having modification, so we can give room for that also. Now let me be quick with this. I'm trying to explain as I go, so everyone is carried along. I could just run. in a way that everyone can understand what exactly I'm doing, in this. Now, okay, let me quickly repeat this because I close this. So I'm modeling out my file object again. That's what I'm doing right here. Okay. Um, Description. It's going to be a string. Be a string. Created that. It's going to be an integer. Owner. It's going to be an address. And the hash. The hash is going to be a string. Okay, so let me close this up. Let me close this up. So the next thing we're doing is to create a record. Also, be um, giving it, we're modifying these records to say to give it modifiers in case there will be anything, in case going forward we'll be having changes, to our smart. Okay. There's gonna be one. There's going to be one. So now we give this an index counter, and we're going to set it to the value of an integer. Then we're going to also have our files. We're going to also impute the map type. The map type, it's more of a dictionary to, to say. I will explain this also. Let me just quickly write this out. And so we're going to say we're going to give it an index counter. Um, so it's the value. Then, as remember, we can upload more than one file. It's a file application. It's a dictionary application for uploading files on the blockchain. So you can upload more than one file. You can upload more than one images. So that's why we're having files, for that. Int, then file. So we'll close this up. So what we did here is that I'm going to be very careful so I don't close this. Also, now we gave it an index counter, sending the value of int to say how many index counter is saying like how many images, 1, 3, 4, right, for example. Now the map keyword is more of a dictionary or an array. It takes the file and assign it the value. We take the file and we assign it the value of an integer. So this is more like a dictionary. Let's come here to see this also in Sophia documentation. Okay, the map is an immutable key value store with dynamic mapping of keys of one type to values of. So that's an example. Now you can see an example: type to account, map to string and address. So an address is what? A string. A string. Yeah, address is a string. Remember, yeah, let me show you this also so that I can use this to explain what I mean. Now remember, here we say the owner is an address. Now remember the here also the example here, the address was mapped to a string. It's more of like a dictionary of the same value types, the same type of value, the same value type. So what we did here is that we mapped the file, which is going to be an integer. We mapped the file to basically what we did and gave it an index counter to be able to know how many images has been uploaded. So that's just the basic what we just did there. Now let's go on. Now next thing we'll be doing is I'll be creating a function. We'll be creating a function that would we'll be creating a function, that will keep track of everything we'll be doing on the smart contract today. Now, functions in eternity is not written with functions. For example, if you're using JavaScript, you're using the ECMA6 and all those and the modern JavaScript, you can use the keyword function to state a function, for example. But right here, eternity does not have the keyword function writing out your functions also, which are basically called entry points. Now they have the entry point is more of saying your smart contract is going to be a public one. We have private. You can write a smart contract to be private, and you can write it to be public. Writing it to be public means you want people to be able to interact with this. For example, you are connecting this to your client and you are building a front end for it, so people can freely interact with this on the front end. So that's when you now be using the word entry points. Now you can come here to see all of this, on the documentation. Now eternity uses modifiers as a way of stating functions. Modifiers as a way of stating functions. Like we have private, we have public. A public um, function in eternity is called an entry point, which gives room for testing. The client side, it's going to be a public one, so people can interact with this also. Okay. Now this function, the entry point is going to call is going to be able to you're going to be going to be able to interact with your smart contract. It's more of initializing, to be called when initializing your smart contract. Okay. So remember, I will just explain before I write again the code. Remember, the entry point is a function to say what that your are going to be assigning the value of an init to it. The arguments are going to leave there. You're going to be start of 0. Then we also we are going to be having the files, and we are going to give it an empty argument. You get? So because we want it to be able, so we want to be able to create new file record, like uploading more images. So we love to add, we want our smart contracts to be able to be open to add more than one images. For example, I create an hash, I upload a file on IPFS, and I upload. Now it will be able to get the file I uploaded using the file object I modeled, my information on the file object, which is immutable. One, my ID, my name, description, the date was created, the time I updated is the address, which is the owner. Now with the address, to know that I upload an image on the blockchain, I also call it. It will also use the file object, and we're using the address of Josh to say, okay, Josh is the one who uploaded this also. Okay, so I believe this explains that. very well. So I don't just want us to come here and write code. I want us to be able to understand what we are doing and what we are writing out here. Now, the index counter will also track the number of files saved. Like I explained also, files saved by the owner because it's going to be the entry point means we are saying this is public. So anybody can come and update their file. Anybody can come and interact with this and also see files updated. That's why we're using the entry point function to say this is a public, a public smart contract, and anybody can, interact with this also. So let's go forward and do this here as I've explained. I believe that's a very comprehensive one. Uh, and in it now, so we'll do that. Remember, index counter, we set it to the value of 0 because it may change, so it can count from 0 upward. So set the value of 0. Then files, we leave this argument empty. Leave the argument empty. That's what we are doing here. So a smart contract public. So that's what we do. So next, remember, we are still in the first aspect of doing this, which is number one. We are still in number one, which is number one. What we are doing in number one, we model our file objects, and then we are creating functions that will make this public for people to be able to, update files, and we'll be able to get these files, to keep track of the files updated. So the next thing we'll be doing is we are going to be setting out get file length, which is we're going to create an entry point function to get the length of files in the smart contract. So that's what the next thing we are going to be doing. We're going to create to return the total number of files saved in our smart contract. So you're going to see that when we deploy our smart contract, so we'll be able to see how many images has been updated on our smart contract. So that's the next thing we are going to be doing right here. Okay, entry point function means our smart contract is public. So let's quickly do that because I want us to round up very quickly. Now we're going to create the entry point, and we are going to have a get file length. Get file length. I'll explain why smart contracts, because this is more of the technical part. So I want us to be done with this as quickly as possible before we go on to the get file length. Going to get the file length. Okay, let's go on. Oh my God. Today is Sunday. Okay. Okay. Remember, you have to always utilize your tab. You have to utilize your tab. Take note of your indentation. This code that I'm writing, I've tried to make it as clean as possible. So you take note of indentation. You must indent properly for your code to run properly. So you take note of that. Now we've done that. We've created a get file. We've created a get file, an entry point get file object to be able to get be able to take record of file. So the next thing we'll be doing, we'll be creating an add file functionality. Now we'll be creating what? An add file functionality. Now Sophia, it's a functional programming language. It's a functional programming language, so it doesn't have one of the advantage of function. It's what it gives out, you understand, so the structure and everything. So that's one of the advantage of functional programming. I'll be playing also a video for us to also see that. Also, so the next thing we'll be doing functionality. Okay, now we're going to be using a stateful entry point and add file. We're going to be having a add file. Now we're going to be also pairing it to keywords and key types in eternity. I'll show you also this. You can see, you can see the chain dot timestamp. You're seeing core.color and all of this. You are seeing this also. I will explain what all this is, and I also show us also from the documentation how this came about. So it didn't come from one magic language that is unique. Should have a documentation. So that's what. Now let's go on. Now we're going to be creating an add file functionality. So let me quickly do this. A stateful entry point. Let me show you why this is a stateful. Why we are using the stateful keyword. Let me quickly show you guys from here why we are using the stateful keyword. Now stateful function, let me show you this now. Top level functions and entry points must be annotated with the stateful keyword to be allowed to affect the state of the running contract. So the stateful keyword also gives us room to say, because remember we are creating an add file functionality, so we want this add file functionality to affect our contract for us to be able to add file. So we'll be using the stateful function. It's a top level function, and it said top level functions and entry point must be annotated with the stateful keyword to be allowed to affect the state of the and give it without the stateful annotation. The compiler does not allow the code to put. Okay, we also see this put later on, and we also see it now. If you come here, you see chain.span. I also show us where without this is not, it doesn't have the full stateful functions that we can use here, but I'll show you also. Let me just show you guys now other stateful functions that you will see there. Let me show you this. Some of the stateful functions we will be using, or we will use in our smart contract. Let me show you guys this. Okay, this is for assessing. Okay, this is not what I wanted to show us. Let me show us this. Okay, it should be this one. All right, let me show you. Okay, that's the dot chain. For example, like I showed you all here, let me show you from the smart contract. In creating this stateful function that will be able to add files to our smart contract. Let me show you. Now, in creating this stateful function, now remember in the stateful function, we then create a function, we say let's start file, then we start pairing remember our file object that we model out. The ID will be get file length, which is the integer that we used earlier. The name will be the name, description, the description, like we modeled out in our file object, which is immutable, like we said before, created at chain.timestamp, updated chain.timestamp. Now, this is what I wanted to show us. This chain.timestamp core.color. They are all stateful, functions. They are all stateful functions. Now, if you check here, you see the chain.spend, oracle.register, and all of this. Now, this explains further what this is. Let me quickly show you guys here. The chain, the dot chain. Let me show you guys. Let me quickly show you how I came about all this also. Okay, now check here. You see chain.balance, chain.block I, chain.block hash. But what we use is chain.time stamp. Okay, this is what I wanted to show us here. Chain.time stamp, which we use here to also know the time this was created. So it's a pretty much comprehensive documentation for you. You don't have to do much. You just know what you want to build, know the types to use, how the Sophia programming language works, and come to the compiler, and you then go to the documentation to pick out your files, and then go through the documentation to know the types, the way to your indentation, and all of this, and you then begin to apply. So that's why it's very easy to use. I did this yesterday, so it's not really something that will be hard for us to learn also. So remember, we are creating a stateful entry point to be able to what add file. Remember, it's public. Like I said, the entry point means it's a public smart contract, so you can add yours also. So we're creating a stateful entry point to be able to modify our contract, to be able to what add files. So let's do that quickly. So we've created a stateful entry point. Now we're going to be, which is going to be the add file. Which then be, remember, it's going to be our name. It's going to be our name, which is will be the value of a string, the value type of a string. Okay, the string. Then remember to always use the comma. In programming, for we all know this. If you do not put your, pay attention to the syntax, you don't put comma where you're supposed to put it, the program won't run. So pay attention to this also. Next thing, the description. We are giving this, we have the description, which is going to be a string. I hope we all took note of the explanation I did. So this is not looking strange for us. If you took note of the explanation I did and why we are doing this, you'd be able to just understand. This is like a walkover for everyone to know what exactly we are doing here. That's what. Now we would then set this. We then set this also. Now we've created this stateful entry point to be able to say we'll be able to add file. Now remember, in adding file, for example, when we deploy this smart contract, if we deploy, you will see all this, and I will come back also to explain. When deploying a smart contract that you want to add your file, after we deployed, you are going to be doing this using theory methods or keywords, which is going to be your name, the name, for example, success. That's my image. The description, success image, and the hash, the file hash. The file hash of. So that's how we are going to be adding. We are going to be adding words. We are going to be adding images on our smart contract. Okay. So now let's quickly do this. Okay, I think I have to indent. Okay, now let's let's quickly do this. Okay, I'm already seeing an error. Let's go further. We'll definitely know where we are getting the error from, and we'll work on that. Now remember, like I explained earlier, now in adding our file is going to be, we are going to be adding with our name, the description of the file, then the hash which we will get from IPFS. Now let's start file. Now we are going to be, let's start file. Let me come back here and explain. So now we are going to then take this our file objects that we modeled out up here, our file object that we modeled out, and we are going to then interact with this also down here also, and set it to, first of all, start file. We are setting the ID to the get file length, which we did there, which is an integer that we did here, entry point function, get file length. Then the next, which we set it with state.index counter. Remember up here, index counter of 0. So we are counting from, if we added a new file, we are counting it from 0, 1, 2, 3, just like that. So we are giving it a what? Get file, which is going to count from +1. Now we're going to set it to the +1. So we are saying 0, 1, 2, 3, +1, +1, +1, +1, 1, 1 +1, 2, 2 +1, 3, just like that, +1. Now the name is, we are going to set it to what? The name. The description is going to be the description. They created that to be a timestamp, which, remember, we gave it the value of an integer up here. We gave it the value of an integer up here. So it's going to be a timestamp, which is an integer, like I showed you all there. Showed you all from the, it's a stateful function also. It's a stateful. So the updated also is going to be a dot chain timestamp, a chain dot timestamp. The owner is going to be call.caller, which I showed you up. And now the call.caller is going to be the address of the caller, like we did here when we were modeling out our file objects. The owner is going to be the address. Then the hash is going to be what? A string, which here the hash will then be the hash, which we get from IPFS. Okay, so let's quickly do this now right here. Let's quickly do this. And so that we can go further. I hope you are following with the explanation. Hope you are following with the explanation. I think my length is not correct. Try this. Okay, so let's come down here. Let's go on. Now remember, the ID is going to be get file, which we already set it to an index counter from 0, 1 upwards, like I said before. Now the argument, we are going to give it an empty argument, and then we are going to set the value of +1, because we are going to be counting from 1 + 1. If you add for example, remember the default value, it's 0, so it's counting from 0. So we don't have any file added yet, but when we add a file, it will then be 1. You understand? Then we add another file, it will then be +1, which is 2. Then we add another file, it's going to be 2 + 1, which is 3. Okay, 2 + 1, which is 3. Now let's go on. Remember, we modeled our file object earlier, so we are now setting our file object to values so that we'll be able to interact with this also, and be able to interpret this, and we'll be able to utilize those file objects to be able to add file. Is going to be a description, like we've done here also. The description is going to be the description. The name is going to be the name. Remember, we've created a stateful entry point of add file, which will be the name, description, and the hash. So that's why we are now having underscore because we've stated this up here. Okay, so it's going to be underscore description. So let's underscore description. Then the created ad is going to be chain what dot timestamp that I showed you all here. Chain dot timestamp to get the time is what was added, which is an integer. I remember that we said our created art is what we set it to the value of what an integer. So this where is now making sense of what we did here when we modeled out our file object. Created art, we set it to what the value of an integer, which is a timestamp, and in doing this, you then be the chain dot timestamp, okay, which is an immutable one. Okay, so let's go on. Which is chain dot timestamp. Okay. Now, if you take note of this, now I wrote what chain dot timestamp, and what we have, we don't see any difference between this. Now, it's supposed to have a different interpretation from the normal description that we had. Now, what was exactly wrong here is that I used what a lowercase. Now let's go on. I use a lowercase. If you come here, chain, it's in uppercase. Take note of this. Chain dot timestamp. The chain is what starts with an uppercase, so it didn't display. Now let me write it so that you see what I'm actually trying to explain to you guys. It didn't display appropriately as it's supposed to display, because now it's like a function where it's not displaying as that. So why? Because I use lowercase. Now if I do this again, now you can see that it's working properly. Okay, so let's go on. Okay, so take note of that. Also, the chain is always written in what capital letter. The chain starts with a capital letter. So updated at, set it to the value of, remember, capital letter, chain dot timestamp, chain dot timestamp. Then the owner, which is the core.color, like I showed you, core.color is the address of the owner of the file updated on the blockchain. Okay, which is the call. The call is also in what capital letter. Take note of that also. Then we then have the hash, which is going to be hash. Now remember that let me close this up. I explain. See, we are having an error. Good. Know where the error is coming from. Then we'll go further and further and further. Okay, now remember I said, now in adding a file which is a public, the stateful, which is, we are saying we are giving room for to be able to add file. We are creating an add file functionality. We are adding files with three, you know, with three we are going to be adding files with three key values, which is the name, the description, and the hash. The name is a string, the description is a string, and the hash is a string. Now, if we deploy our smart contract, you will see this in action when we begin to deploy. You see that when we want to upload an image, it will be the name, which is success, that's my image, the string, which is success image, then the hash, which is the hash you get from IPFS. Okay, now we've done what we've created. We've taken this um, file object, and we've paired it to value pairs that would then ensure that our file object and begin to give us what we want. Now we'll then set the index to, which is the get file length. Then it's going to be a level plus one like we did up here. Then the put keyword, remember, let me come back here and so that I'll show you this. Now remember, this is a stateful function, which is this is a stateful function to be able to say top levels entry points must be annotated with stateful. So now this is stateful, and we've used some stateful functions like the chain dot timestamp and all of that that we've used. Now this also put is a keyword. You cannot call the put keyword without using the stateful annotation where you can call. That's the only way you cannot call the put keyword. So if you come here, you see we will say put states, which is the state of our smart contract. State will be then files, then set to the index. The index will then be a key, the key value, then the store file, which is the index counter, which you set to the value of index. So let's quickly do that. So we'll be able to add file before we then retrieve. We'll then create a function, an entry point function for what retrieving the files that were added. So let's quickly do this. Let's quickly do this. Oh man, today it's an amazing day. Programming is one of the aspects that blockchain enthusiasts and guys we haven't really begin to look into this aspect and see how we can be able to learn this, because today we know that software developers are one of the highest paid in the world, and blockchain technology is the future. It's one of the key feature of technology. So I remember the put said in the state. Now it's very unique for us to begin to learn blockchain development, and that's why Sophia is a very easy to learn and get started with blockchain development. For you to get started with blockchain development, so we set it to what, which is the index. Okay, to ensure I'm doing, which is going to be index counter. Okay, so we've done that already. We've created our add file functionality by doing this. I think we need to have space here. Remember, it's the compiler is very sensitive. Takes record of. I'm having an error. I'll definitely know where the error is coming from. All right, so let's move on. So we are done with creating a function for adding file. Okay, now the next thing we'll be doing now will then be creating a function for retrieving files. We'll be able to then we also use the map keyword here also. Remember, we use the map keyword, which is up here. Use the map keyword. Up here, let me when we say our file, set it to what integer, and give it index counter and all of this. We use the map keyword here to say it's a map keyword is like a dictionary and an array. It's kind of popular if you are doing program, if you are a developer before, you understand this well, that we're going to be creating an entry point to get file by index to retrieve this file. So remember, we added file here, and we want to retrieve the file down here also. Okay, so now we'll then create an entry point to get file by index. We set it to the value. The index is going to be an integer, the index like we did 1 0 1 2 3 4, and then the file we then switch to what look up. We'll then look up this, which add file functionality that we've done here. We then look up, map the lookup to say if there's any file in here, return the file. Understand? But if there's no file found like that, send an abort statement, which is file does not exist with this index. Okay, so if you are looking up our contract here, we are going to do to retrieve one, to also look up to say if the file exists, return the file, which is the hash of the file, because we are using IPFS. If you are connecting this to the client end, which is HTML, Java, and building the front end of the D app to interact with the back end, which is the smart contract, you then see that this map, the lookup, will then display the image in the front end, create to ensure that whatever is not imputed in our smart contract does not come out from our smart contract. So we ensure security and all of that. So let's create this entry point functionality for that also. Okay, so let's create that also. Now the entry point, remember the entry point say that our contract is what is public. It's a public function to say it's public. So now it's, let me get file. I hope you are having a nice time. I hope it's not too techy and too boring for you guys. But that's why we would have this video available after now, so you can always go back, watch this, and you can also go on darkade.org to get a more interactive video with all of the cartoons, the illustration, and all of that. All right, now what we are doing here, we are creating a function for us to be able to retrieve. I'll take note of the tab. Now remember, I tabbed. You must make sure your indentation is correct. I'm doing this again and again, so you can take note of this. I'm going to be using the switch keyword so that we can be able to look up I'm going to be using the keyword of map. The lookup. Let me use the capital letter. I think it also applies here. Let me do this. Okay, the lookup. Now, there's a difference between this map up here. Let me explain this before we go on. Now, the map that we look up here is more of like a dictionary to say look up and say if there's like we were saying index counter of how many images, like an array or a record, a dictionary of how many images or files that has been uploaded. So you can count 1 2 3 4 5 6 7. Now, according to the number of images that have been uploaded. But here, this map.lookup does a different functionality on its own. Now, the map.lookup now checks the index to see if there's any file with the hash, or if there's any file that exists with that hash on the blockchain, and then displays this. So this is looking for the file on or uploaded on the blockchain, but this is checking for the number of files, more of like a record. a dictionary to say, the number of files that has been uploaded. So that's for that. So that's the basic difference of that. So we don't now remember you use the capital letter. If I use the small letter here, it will just assume that it is a normal map keyword, and it won't work for us properly. So ensure you take note of this also. Take note of this also. Now let's go on. This is going to be index. So it's going to be states. Guys, let me close this up. Okay, so we are using the switch statement to say if look up the files updated. Remember we've created an add file functionality. Here we're now creating a retrieve file functionality. So you're saying look up this if the file does not exist, trigger an abort statement that says file does not exist. Now, even if you're connecting this with your client end, you are using your client end to connect this. If you now you're working with and you created a front end for your D app and you interacted with this. Now, if you use your Chrome developer tool, to check if, for example, you imputed an hash and you couldn't get it. Now, if you use your developer tool to check, you will see where it tells you where the error is coming from, and this is going to be the statement that is going to be displayed. The display statement going to trigger this statement also. So I'm just giving you an hint. If you are taking the course on that, this course teaches you how to take your smart contract and interact it with the client end. Because of time, we'll be going into all this, so you can come here and take the full course on that. So there's now with the index. Okay, so we are saying look up does not exist, return the error that it does not exist. But if it exists, return the file. Okay, return the file for us. All right, so that's what we are going to be doing here on this. So if it exists, return this for us. Okay, wow. I'm actually looking through my key part to look for that for the X. Please let me. All right, let me. Okay, fine. Wow. Please bear with me. Bear with me. I think I found it. Okay, since I can't find, let me just copy from utilize. I think it's because of the lights and I can't really see that now. So what we are doing now is saying if it does return, we are setting to the value of X, which is a kind of default value, So we are basically done with our smart contract, and we are behind time already. So we just quickly deploy this. Okay, I think the issue here is indentation. There's nothing. There's no error here. Let me refresh this so we can deploy and test our smart contract. So we are basically short of time. So let's just deploy, test, and then we will be done for today. Be done for today. Okay. We're still having error. Let me see if we still have this also. Okay, so we are basically done with our contract. Okay, so all right, the error is coming from here. So that's one thing. I will have to debug and debug and debug, but I'll try to make it quick. So I'll definitely know where we are getting the error from. So we should be basically done with this. Let me see if I can refresh this. Okay. Okay. Why is this giving us an error? Let me indent a little bit and see if that's where we're getting the error from. Okay. All right. Okay. There was a mistake here. I made. Let's quickly debug this. We can test. We are short of time already. Okay, there's no comma here. We're not supposed to have a comma here. Okay, so put keyword. Let me indent and see. What's the issue with that put keyword? We're not supposed to be having any issue with this. Um, okay, let me basically refresh and see. We're not supposed to be having any issue with this. I'm not supposed to be having any error with this. So let me refresh and let's see. Let's see so we can deploy our contract and test it. Go. Okay, line 33. Okay. We're not supposed to be getting this error, but let me quickly go through this and see where we may be getting this possible error from. Okay. Everything looks good. Um, Everything basically looks good. So do not know why we are getting this error. So I don't know why we're getting this error. So let me see if I get it to work. Okay, so basically, let me just let me because of time and the I would have debugged this and go through step by step, but because of time, um, the lead already told me that we are behind time. So I'll just go to my GitHub repository and I'll copy, the one I already did and debugged before, so that we can just use that to test. But it's pretty the same thing. If you followed us, all the explanation I gave, it's pretty much the same thing. So I will just, instead of debugging because of time, I will just use this and so that we can test, deploy, test, and get this. So Control A. This now, we have this now. So shouldn't be having any error with this. Okay, so let me refresh this so that we can deploy and go. So basically, what we did here today, and I made sure I explained everything. I break like I ensured that I was able to break everything down for us to understand what we are doing here. Well, what we did on our code, and building this. So this is for this. This is, you can get this from my GitHub repository. I'll give the link. You can also, let's deploy now. This is our completed smart contract. Let's deploy and see what we did. It's very, the AI Studio is so unique that you can build your smart contract and test it before taking it over to your client side. So we've deployed it, is deployed successfully, contract successfully deployed. The name of our file is smart, the address, the transaction, the address. So if in case you are working with your client side, you come here to copy this address. So it's deployed on this address. So you copy this and then interact with your smart contract using this address from your JavaScript and from the front end of your decentralized application using JavaScript or any the programming language you so intend to do. So now let's add file to this. Remember, this is where this comes into play. This entry point that we created, stateful entry point of add file name, which I explained, the string, description, which is a string, then the hash, which is a string. So this is where it comes into play here. Remember, here is a string, the add file, we're adding file, the name of the owner of the file, description. Then here is the name of the owner of the file. Here is description. Then here is the the hash that we created for that we got from where, from IPFS. So now let's quickly do this and see. So the name of the file will be success image. The name of name of the file, okay, let's say an image. Then here will be success image. So here we then have the string, which is the hash. So let's quickly go here. Okay, let me do this again. So in case we didn't follow how to upload file, so let's choose a file using IPFS. Let's choose a file that will be uploading on my PC. So I'll be uploading my image. So let's quickly do that because we're out of time. So let's just quickly test this and go. So this is the image. So let's, okay, I don't know why we're having this. Let me refresh this. Okay, sorry, the image. So let's copy this hash and then come here and put it here. So now let's test this to see if our smart contract worked perfectly well. If we can get the file, okay, successful. So it was successful. It was successful. Call successful. So this is the hash of the image. If you copy this now and put it in Google Chrome, you see in your Chrome browser, you see the image is the hash of the image, the color ID. This is the color ID that we call, you know. Then this is also then if you which is the length, like I will explain this. Now we see that we've added image, one image. Now this is seen here. This is what we did here to say entry point get file length to say that we did here when we set the value of the ID to set it to the value of 1. So if we add another one, we will then get 2 instead of 1. So that's 1 plus, like I explained before, 1 plus 1, 2, and so on and so forth. So our smart contract worked perfectly well. Now, this is the kind of the back end, so that's why it's very technical and all of that. So we've successfully written a smart contract to add and retrieve files on the Eternity blockchain. So that's what we have successfully done. Now, if you want to interact with this on the front end, you come on dark.org and take this course, Introduction to Eternity Development. You are going to be learning how to, you know, show you this how to the HTML. This is it, the HTML and CSS of the D app. You're able to know how to work on the front end. You also have code examples here, JavaScript of the D app. You also have the front end, which is you also have. Then you also know how to, like we showed you, which I told you that you're going to do it with an SDK in your JavaScript code. Then you then test and you see that it works. So we'll be going into all that. So I'm just going to focus more on the technical part, which is kind of the more difficult part in quotes, because many of us we are familiar with HTML, CSS, and JavaScript, but we are not familiar with Eternity smart contract. So that's what we've successfully done. We've deployed our smart contract. You can come here to get the full documentation. Now, let me quickly show you an amazing feature before we go. Now, if you are deploying this on the mainnet, for example, you want to build an application for adding and retrieving file on the blockchain. Now, we did this on the testnet, or you built an application for keeping record of exam score, and you want to make sure that you don't have cheating in the exams, or you are building the application for voting on the blockchain. And after writing your smart contract on the testnet, and you've tested, you've deployed, you've tested, and it works perfectly well. Now, if you want to take this to the mainnet, you need to then pay. Now, remember, here you are using testnet tokens to test your smart contract. Okay, that's what you are doing here. But if you want to take this now, eternity tokens. Now you can do this with connecting your application to the Superhero wallet. You can get this from Chrome extension. This is it. Let me show you quickly this. You can get it from the Superhero. So you can I already added it. So this is the Superhero wallet. Now, what is the Superhero wallet? Let's quickly go through that. So for those of us that love to take this to the mainnet. Pyro.com. Those of us that love to, after writing our smart contract with tested, and would love to bring it out there for people, for public utility. You then know how to connect with, to be able to spend real tokens. This is superhero.com. Now, this will also lead us to discussing shortly about cybersecurity and use cases for cybersecurity. So this is what I wanted to show. So you can connect this with your wallet. Now, let me show you the extension. If you add that to your Chrome, you can then, you can then, um, you know, interact with this. by a wallet extension. Let me quickly show you mine. Let me quickly show you mine. So let me quickly show you my wallet. So I've enabled it, so I can quickly show you my Super wallet. So to spend the real token interacting with the AE Studio, like I showed you, I have some tokens here in my wallet. So you can then interact with this. You can then interact with this and also spend reward token using, and taking your stuff mainnet. Now you won't be spending all the amounts. If a user wants to also add images, the user has to connect to his mainnet, and the user will spend tokens, to interact with this. So that's a unique feature for this. Now let's talk about the superhero platform. This is it's more of a social platform. What it aims at doing, let's quickly go to frequently asked questions so that we can know what superhero is. Now, superhero is a social media platform, that is done right to ensure that we do not have the issue of um, we do not have issues like censorship. For example, we talk about cyber security and we talk about how people steal your information. We know that most hacking happens not because they got your information from a place that they couldn't get it from. They got it from places that they can easily get it, like platforms like the Facebook. That's where they got the information from. So information are gotten from where? From Facebook in most cases. And Facebook is one of the unsecured application out there. They basically control everything about the user. They can sell your information there, and that's how the superhero platform came about, came into existence. Okay. All right. So that's for that. That's how the superhero platform came into existence. Now, what is the superhero platform? It is a social media done right, no censorship is or whatever. You are secured, you are safe. Remember, blockchain technology was created to remove centralized authority from the space. For example, we are using the DNS. So we'll talk about cyber security for DNS, domain name service provider, seeing how we can ensure that this is safe for us who are developers and all of this. Now, no hidden agenda. Superhero is free for all to use and does not take commission from tip cents. For example, you are using tip cent, and that's when you are sending tips. Superhero for everyone by everyone. If you're a developer, you can create an application and publish on Twitter, and then you would have you'll be tips for it. So because this is not basically a tips a more of a theoretical, I would try to focus explanation to cyber security because it's a cyber security community. Now it's censorship free, so there's nobody tracking your activities or whatever on this platform. So I just wanted to show us this. If you want to spend real token in your smart contract after creating on the test net and you want to publish on the mainnet, you can use this also. So let's quickly round up by discussing use cases. I love the lead Josh to get so that we can to turn on his speakers and so that we can quickly just discuss basically on use cases, and also if there are questions I can answer, and we call it off for today. So Josh, thank you for the opportunity that you've given me today. I really appreciate it. So let's just talk about use cases for blockchain technology and cyber security. Then we would take questions if there are questions. Then we'll round up for today. So just you can.
And being with us here today. We really enjoyed your lessons on and your lessons were really big blockchains and security. All Giantsec members are security conscious people. You've shown us that there are platforms on the blockchain that supports privacy and zero censorship, which is something
Yes.
a lot of security enthusiasts want, right? So, are there other platforms apart from superhero.com that allow that offer the same features with superhero.com?
You asked a question.
Yes, I was asking, we all love platforms with zero censorship and all, and you've shown us
Yes.
superhero.com, which
Yes.
runs it's mostly running on the blockchain. So I wanted to know if there are other platforms and let's say maybe forums that are very security friendly like superhero.com on the blockchain too.
Okay, basically for there are other platforms out there which you can definitely make a research on. But because this is an eternity event, I
Okay.
would narrow everything down to eternity. I showed you a very platform which is
Okay. So
all
yeah.
of yeah. Go on your question.
Yes. So thank you very much. Thank you very much, success. Thank you very much, success. I don't think we really have much questions on entities blockchain because you really did good in your explanations and all. We are going to contact you if we have much more questions and I'll have you. So we
All right.
I would like to say thank you very much on behalf of the whole of Giantsec.
All right. Thank you. Would like you mentioned about having an eternity course on the academy that will be launching, that your community will be launching. We would love to have that also. And what we also love to
Yes.
make provision for an advanced course on eternity development, talking about working in oracles, state channels, and all of that. So we would love to provide that also in the academy. So let's see how we can talk and work on that after the event. So thank you for having me. Thank you all for tuning in. I hope I was able to share value and explain in a way that everyone can understand. And if it was a more of a theoretical meetup, we would just be talking about blockchain and trying to know, but this is more of a practical workshop. And I hope everyone enjoyed it. And we also have a good package for those who tuned in. So we'll communicate that immediately after the event. So thank you all for having me. Thank you all for tuning in. Thank you all. Thank you all. Thank you all. All right. We call it
Thank
an
you,
evening.
success.
All right. Good
All
night.
right. Good night, everyone. Shit.